Alright, this is going to be the supersonic flow through a converging diverging nozzle simulation. So we're going to start a sketch on the front plane, make our inlet, go. And we're going to take a 3-point arc here. We're going to make our throat. Do that again. Go to here. And then our diverging. So a rough sketch, first thing we're going to do is take all these, make them tangent to each other. Delete that. There you go. Alright, so that is our throat section. Let's draw a center line here. Let's make this a little bigger. Okay. And then let's close this. And we'll make this twice as large. So A by A star of 2. Check, yep, that's for the throat here. So now what we can do is click mirror entities. Go ahead and select everything. And this as well. And then mirror about the center line. And that should, select this as well. There you go. That should be good now. Boom. So now this is our nozzle done. And then we'll just do some smart dimensions to make him fully defined. Here, here. Okay, so when we finish our sketch, we can go ahead and exit and then go here, insert, surface, planar, select our sketch, and then done. And then what we'll do is we'll save this as an IGS file. Here. And then click save. And then once we save that, we can hop into ANSYS Fluent and import the model from there. Okay, so now we're here. Create a new fluid flow Fluent. We're going to first change analysis type to 2D. Import. And then CD nozzle. open design modeler. We're here, now we'll click generate. Boom, here's our nozzle. So we should be good now. We can just close this. Go to mesh. Wait. Okay. Oh, okay. So we'll right click, insert sizing. And then we'll change, we'll try 0.03 for now. And then we'll just click generate. Okay, so our mesh is done. We've made it a little bit bigger just to speed it up, but here it is. What we'll go into now is we're going to click edge, and then we're going to select our inlet, right click, and then named selection. Create named selection. Here it is. And name this inlet. Select our walls. And then select our outlet. So we should have inlet, walls, and the outlet. That should be everything. Now we close the meshing. Right click, update. Alright, now that's done, we'll go to setup. Double precision, I'll put 4 for processes. Alright, first thing we'll do, we'll check, make sure our mesh looks okay, no negative volume. We're going to go to density based solver, models, energy on, and then materials, air. Change this constant density to ideal gas. Change and close. Okay, and then what we'll do is boundary conditions. Inlet, change to pressure inlet. Okay, and then the values I chose are 212.86, and the static pressure of the inlet 200 kilopascals, or 2,000 or 200,000. We'll keep the temperature to 300. And then the we have an A by A star value of 2, so the outlet pressure should be around 20 kilopascals for perfectly expanded. We'll go 10,000, go a bit lower, just to make sure we have supersonic flow, and the temperature will be around 120. And then I think that's pretty much it. We'll initialize. Okay, and then we're going to run 2000. It should converge before then, but we'll just try that, and then we'll come back whenever this is done. So it's now finished. Okay, there we go. All right, so we're going to make contours now. So let's go to graphics, right click contours, click new. And the first one we'll do is the Mach number to make sure that it has gone supersonic. So velocity, Mach number, all of these. Save display. And beautiful. So as you can see, subsonic at the start. Let me change this. So yes, like I said, around Mach 2.23 at the start, hits the nozzle and then accelerates up to Mach 2.29. So we have hit supersonic flow through the CD nozzle. So now we're going to make the rest of the contours fairly simple. Velocity, just change this to velocity magnitude. And then same thing, select all of these. Save display. Very similar story. Slow at first and then accelerates with the boundary layer, of course, staying at 0 because of the viscosity in the simulation. What was it? Density, I think it is. Here we go. So Mach number and velocity will follow the same trend, and then pretty much everything else, density, pressure, speed of sound, all that will follow the opposite trend. They'll start higher and then slow down or get lower as you go. Let me just click that. So that's pressure, and then speed of sound, properties, sound speed. And once again, same trend as all the other static values. Change this to float. And then there should be one more, pressure, density, oh, temperature. So new. And then temperature. There we go. So all the contours are done. And then as you can see, temperature starts at just below 300 and then goes down to about 146 Kelvin. Next thing we have is the plots. So we'll get those done now. Alright, so if we go here back to general and then hit check. Okay, it's done. So you see that the max X is going to be 1.01 something E plus 1. Okay, so that is going to be the max length of the part pretty much. So like 10.2. So we're going to go to right click XY plot new. And then we're going to create a new surface, line rake. And it's going to be at Y0, 0. And then it's going to go from X is 0 to that, what was it, 10.11. We'll do a little bit past the end. And then we'll call this center line. And create. So that's going to be the line that we plot all of our graphs with respect to. So we'll do pressure and then just select the center line and then save and plot. And here we go. And that makes sense, right? The pressure starts high and then it's dropping constantly to a low value at the end, right? Let me change this. Perfect. And the way ANSYS works is that everything is gauge pressure, so these negative pressures just means that it gets below atmospheric pressure. So nothing wrong with that. So we'll do velocity. Velocity, same thing. Everything is on just the center line. Here we go. And then the same thing as the contour, right? Opposite trend is pressure. And then what? Density. Center line. Save plot. And again, same general trend as the pressure. Everything but velocity and Mach number will be starting higher and then going down. What's it? Speed of sound next. Properties. Sound speed. Center line. There we go. What else is there? Temperature. Plots. Boom. Good. Last one. Oh no, sorry. Velocity. Mach number. Center line. Plot. So now we have all of our plots. Mach number and velocity are going to be pretty much the same, right? Starting lower and then gradually increasing across the whole nozzle. Everything else will be the opposite, with a high value at the start and then a constant decrease throughout the nozzle. And all of these match up with our contours, right? Low to high. So that should be everything for the first simulation. Next, we'll do the case with the shock.